NFPA 70, the National Electrical Code, addresses the requirements for electrical installations, including those with multiple power sources. Article 409.2 specifically requires a disconnecting means for each source of supply. Article 240.4b necessitates overcurrent protection for each ungrounded conductor. Considering a main cabinet with a 480 volts 3-phase 40 amp service and a 115 volts 30 amp service, along with a second, smaller enclosure supplied by the 115 volts service, several factors determine code compliance. Firstly, the disconnect switch in the main enclosure serves as the disconnecting means for both the 480 volts and 115 volts services. Secondly, the 115 volts 30 amps breaker in the main enclosure provides overcurrent protection for both cabinets. Based on these NEC requirements, an additional 115 volts breaker in the second cabinet is generally not required, as the 115 volts 30 amps breaker in the main enclosure provides sufficient overcurrent protection for both enclosures. Although the NEC does not explicitly mandate a warning label for multiple power sources, it is a recommended best practice. Labeling the second cabinet with a warning indicating that it is supplied by the main enclosure ensures personnel are aware of the potential for voltage from multiple sources. A suitable warning label would state, "This cabinet is supplied by more than one power source." During maintenance on the second cabinet, it is crucial to ensure that the 115 volts 30 amps breaker in the main enclosure is locked out or tagged out. This prevents potential hazards from energized logic wiring. Additional considerations include the routing of control wiring between the cabinets. If the control wiring is routed through conduit, it may be necessary to install a conduit sealer in the second cabinet to maintain the integrity of the electrical system. To elaborate further on the NEC requirements, it is essential to understand the definitions and applications of disconnecting means and overcurrent protection. A disconnecting means is a device or group of devices by which the conductors of a circuit can be disconnected from their source of supply. This device must be readily accessible and capable of being locked in the open position for safety during maintenance or repairs. Overcurrent protection is the protection of conductors and equipment against overcurrents exceeding their ampacity. Overcurrents can result from overloads, short circuits, or ground faults. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when an overcurrent condition occurs. The selection of overcurrent protection devices must be based on the ampacity of the conductors being protected and the interrupting rating of the device. In the specific scenario of the main cabinet and the second enclosure, the disconnect switch in the main cabinet fulfills the requirement for a disconnecting means for both the 480 volts and 115 volts services. The 115 volts 30 amps breaker in the main enclosure provides overcurrent protection for the 115 volts circuit supplying both cabinets. The size of the breaker is determined by the ampacity of the conductors in the 115 volt circuit and the total load served by the circuit. The NEC specifies requirements for the installation and use of warning labels to enhance electrical safety. While a warning label is not explicitly required for multiple power sources in this scenario, it is a recommended best practice. Warning labels should be durable, readily visible, and clearly indicate the nature of the hazard. The warning label "This cabinet is supplied by more than one power source" effectively communicates the potential for voltage from multiple sources and alerts personnel to exercise caution when working on the equipment. Lockout tagout procedures are essential for ensuring electrical safety during maintenance or repairs. Lockout tagout involves de-energizing the electrical circuit, locking the disconnecting means in the open position, and attaching a tag indicating that the circuit is out of service. This prevents accidental energization of the circuit while work is being performed. In the context of the main cabinet and the second enclosure, lockout tagout should be performed on the 115 volts 30 amps breaker in the main enclosure before any maintenance is performed on the second cabinet. This ensures that the 115 volts circuit supplying the second cabinet is de-energized, preventing potential hazards from energized logic wiring. Conduit seals are used to prevent the passage of gases, vapors, or flames through conduit systems. They are typically required in hazardous locations or where conduit passes from a hazardous location to a non-hazardous location. In the specific scenario of the main cabinet and the second enclosure, a conduit seal may be necessary in the second cabinet if the control wiring between the cabinets is routed through conduit. The need for a conduit seal depends on the specific application and the potential for hazardous conditions. In summary, compliance with the NEC requires a thorough understanding of the requirements for disconnecting means, overcurrent protection, warning labels, lockout tagout procedures, and conduit seals. In the scenario of the main cabinet and the second enclosure, the disconnect switch in the main cabinet serves as the disconnecting means for both the 480 volts and 115 volts services. The 115 volts 30 amps breaker in the main enclosure provides overcurrent protection for both cabinets. While a warning label is not explicitly required for multiple power sources, it is a recommended best practice. Lockout tagout procedures should be performed on the 115 volts 30 amps breaker in the main enclosure before any maintenance is performed on the second cabinet. A conduit seal may be necessary in the second cabinet if the control wiring between the cabinets is routed through conduit. Understanding the specifics of overcurrent protection, consider NEC Article 240, which provides comprehensive guidelines for overcurrent protection. Section 240.4 addresses protection of conductors, specifying that conductors must be protected against overcurrent in accordance with their ampacities. The ampacity of a conductor is the maximum current, in amps, that the conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including the conductor material, size, insulation type, and ambient temperature. NEC Table 310.15b16 provides ampacity ratings for conductors based on these factors. When selecting an overcurrent protection device for a conductor, it is essential to choose a device with a rating that does not exceed the ampacity of the conductor. If the overcurrent protection device is rated higher than the conductor ampacity, the conductor could overheat and potentially cause a fire. There are some exceptions to this general rule, as outlined in NEC Section 240.4b. For example, if the ampacity of a conductor does not correspond to a standard overcurrent protection device rating, the next higher standard rating can be used, provided that the rating does not exceed 800 amps. In the case of small conductors, such as those used for control wiring, NEC Section 240.4d provides specific requirements. For example, 18 American wire gauge copper conductors must be protected by a 7 amps overcurrent protection device, and 16 American wire gauge copper conductors must be protected by a 10 amps overcurrent protection device. These requirements are intended to protect the small conductors from overheating due to overcurrents. In addition to protecting conductors, overcurrent protection devices also protect equipment from damage due to overcurrents. NEC Article 430 provides requirements for overcurrent protection of motors and motor circuits. The overcurrent protection requirements for motors are more complex than those for conductors, as motors can experience high inrush currents during starting. The overcurrent protection device for a motor must be sized to accommodate the inrush current while still providing protection against overloads and short circuits. The interrupting rating of an overcurrent protection device is the maximum current that the device can safely interrupt without being damaged. It is essential to select an overcurrent protection device with an interrupting rating that is sufficient for the available fault current at the point of installation. The available fault current is the maximum current that could flow in a circuit under fault conditions, such as a short circuit. The available fault current can be calculated using methods outlined in the NEC or determined by contacting the local utility company. If the interrupting rating of an overcurrent protection device is less than the available fault current, the device could fail to interrupt the fault current, potentially resulting in a fire or explosion. The NEC also provides requirements for the location and accessibility of overcurrent protection devices. NEC Section 240.24 requires that overcurrent protection devices be readily accessible and located so that they are not exposed to physical damage. Readily accessible means that the overcurrent protection device can be reached quickly without having to climb over obstacles or use tools. The NEC also requires that overcurrent protection devices be enclosed in cabinets or enclosures to protect them from physical damage and prevent accidental contact with energized parts. In the specific scenario of the main cabinet and the second enclosure, the 115 volts 30 amps breaker in the main enclosure provides overcurrent protection for both cabinets. The breaker must be readily accessible and enclosed in a cabinet or enclosure. The interrupting rating of the breaker must be sufficient for the available fault current at the point of installation. Moving on to the topic of warning labels, the NEC provides requirements for the use of warning labels to enhance electrical safety. NEC Section 110.16 requires that electrical equipment be marked with a warning if it is likely to become energized while being examined, adjusted, serviced, or maintained. The warning must state the nature of the hazard and the precautions that should be taken. The NEC also provides requirements for the color and size of warning labels. Warning labels must be orange or yellow in color and must be large enough to be easily read from a distance. The lettering on the warning label must be black and must be of a size that is legible. In the specific scenario of the main cabinet and the second enclosure, a warning label is not explicitly required for multiple power sources. However, as previously mentioned, it is a recommended best practice to label the second cabinet with a warning indicating that it is supplied by the main enclosure. This warning label should be durable, readily visible, and clearly indicate the potential for voltage from multiple sources. A suitable warning label would state, "This cabinet is supplied by more than one power source." The NEC also provides requirements for lockout tagout procedures to ensure electrical safety during maintenance or repairs. NEC Section 120.1 requires that electrical equipment be de-energized and locked out or tagged out before any work is performed on it. Lockout involves energizing the electrical circuit, locking the disconnecting means in the open position, and attaching a tag indicating that the circuit is out of service. Tagout involves attaching a tag to the disconnecting means indicating that the circuit is out of service. Tagout is typically used when lockout is not possible, such as when the disconnecting means cannot be locked in the open position. The lockout tagout procedure must be followed by qualified personnel who have been trained in the proper procedures. The procedure must include steps to verify that the electrical circuit is de-energized before any work is performed on it. In the specific scenario of the main cabinet and the second enclosure, lockout tagout should be performed on the 115 volts 30 amps breaker in the main enclosure before any maintenance is performed on the second cabinet. This ensures that the 115 volt circuit supplying the second cabinet is de-energized, preventing potential hazards from energized logic wiring. Finally, let's discuss the topic of conduit seals. Conduit seals are used to prevent the passage of gases, vapors, or flames through conduit systems. They are typically required in hazardous locations or where conduit passes from a hazardous location to a non-hazardous location. NEC Article 501 provides requirements for conduit seals in hazardous locations. The requirements for conduit seals depend on the type of hazardous location and the type of conduit system. In general, conduit seals must be installed at the point where conduit enters or leaves a hazardous location. The conduit seal must be approved for the type of hazardous location in which it is installed. In the specific scenario of the main cabinet and the second enclosure, a conduit seal may be necessary in the second cabinet if the control wiring between the cabinets is routed through conduit. The need for a conduit seal depends on the specific application and the potential for hazardous conditions. If the area is deemed a hazardous location, seals are required. To summarize, NEC compliance involves a multifaceted approach encompassing disconnecting means, overcurrent protection, warning labels, lockout tagout procedures, and conduit seals. Adherence to these requirements ensures a safe and reliable electrical installation. Remember to always consult the latest edition of the NEC and consult with qualified electrical professionals to ensure compliance with all applicable codes and standards. Always prioritize safety and follow established procedures when working with electrical equipment. Furthermore, it is crucial to maintain detailed documentation of all electrical installations, including wiring diagrams, equipment specifications, and inspection reports. This documentation can be invaluable for troubleshooting problems, performing maintenance, and ensuring compliance with codes and standards. Regular inspections and maintenance are also essential for maintaining the safety and reliability of electrical systems. Inspections should be performed by qualified personnel and should include a thorough examination of all electrical equipment and wiring. Maintenance should be performed on a regular basis to prevent problems from developing and to ensure that electrical equipment is operating properly. In addition to the specific requirements discussed above, there are many other NEC requirements that may apply to the installation of electrical equipment. It is essential to be familiar with all applicable NEC requirements and to consult with qualified electrical professionals to ensure compliance. By following these guidelines, you can help to ensure the safety and reliability of electrical installations and protect people and property from electrical hazards.